Cool. And we'll send the recording out to the Luma list, right?
Yeah, exactly.
Cool.
Share. I just started screen sharing. All right. Firstly, hello everyone. Welcome to our first online talk. Um, I think one of the reasons that really inspired don't show again. One of the things that really inspired this talk for us was this whole premise that it's been about 2 years and AI models seem to just be stuck in demo land. And we've seen a lot of apps get actually built and shipped to production for some companies. And we just figured we'd share some of these techniques for most of April with exactly how some people are addressing some of the problems that we have. As you have questions, as you have thoughts, we'd love to make this more engaging and actually like welcome you to ask whatever you want. And then if you have topics that you think are worth mentioning, mention those as well, and we'll try and cover them. But I'll give you a quick background on who we are, and then we'll get to the meat of it, which hopefully is going to be the most fun part, which is actually coding and talking about scenarios and how to make them work. So I'm Vaibhav. I'm one of the co-founders of Foundry, and we make BAML. And we'll be using that mostly for work today. But in effect, any of the techniques we use can be done with any of the AI layers of your choice. And our goal is to really just share techniques. Dex.
Yeah. What's up? I'm Dex. I'm the founder of a company. I spend most of my days building tools called Human Layer, helping people deploy safer, more reliable AI applications. You can call them agents if you insist, but I think we're going to blur that line in the next couple talks, anyways.
Cool.
And
Let's talk about. Go ahead.
yeah, good. I was just gonna say, like,
Yeah.
I think let me know if I read this right, Bob. But I guess the idea is like let's do really hard problems with tiny models to prove that, like, with the right techniques and the right prompting and the right kind of surrounding code, you can even get small models to do impressive things. Because then go apply that to actual big, like, frontier models, and you'll be able to do incredible things.
That's kind of the goal. Like if we can do this with small models, we can probably get away with very large models doing things as well. And I personally have this belief that like GPT 3.5 honestly was already pretty good for a lot of scenarios. There's some scenarios where it doesn't work for, but I've seen people ship really impressive pipelines. I think the only problem that I've seen be a struggle for a lot of models has been SVG generation. But honestly, now with the new image model that GPT-4o released, it's possible that that actually got a lot better just because of how much cleaner the images are getting. But we can talk about that later. Let's talk about the topic at hand today, large scale classification. So when we talk about large scale classification, there's a lot of different applications that people have here. And specifically, I want to narrow down and articulate some of these articulations, but how many of you have actually had how many of you have actually dealt with needing to classify, let's say, over 100 things in your AI pipelines? You can just type in the chat if you'd like. What we've seen, what kind of domains have people worked in? If you want to share like the domains that you worked in, that might help us make sure that we can contextualize as much as possible for today's conversation. Some of the applications that we've seen has been mostly in the medical industry, has been in the regulatory docs has been very common. There's been a lot of stories in the manufacturing space. We've seen some spaces um, in the world of MCP, where how do you deal with an MCP server that has over 1,000 tools? Because LMs are not going to produce that very well. And then we've also seen that really be true in like routing agents. Because if you have a routing agent with more than 20 routes that it can route to, we sometimes see degradation in performance where it starts to pick the slightly wrong routes out there. So let's talk about how we could go and address this problem. And I think to address this problem, the best thing to do is just start off with like diagrams. The biggest thing that we often see is, let me go ahead and open Excalibur. The biggest problem with all these systems is that they're often not very probable. And the minute a system becomes non-probable, it really becomes hard to go edit because now you're at the mercy of the model updating. to actually give you the results that you want. And that just isn't that's just a sad world to live in because now you're stuck waiting for GPT-26 to come out. And if GPT-26 doesn't come out that year, then you're kind of just waiting and twiddling your thumbs. And the problem with tweaking just the prompt is that
Burada kogo сделка
the
Avian.
prompt is actually
İki
very,
yapalım.
very hard to go edit yourself. I'm actually gonna get a mouse really fast. Give me 1 second. Dex, you want to
Cool.
start?
Yeah, I can start sketching a couple things here. So, I think I'm curious, like when VibeUp says probing, maybe drop in the chat. Like, what does that mean to you? Or actually, okay, you're back. Also, if you give me co-host, I can like help mute people and stuff like that.
Yeah, let me give you co-host really fast.
Sorry, technical setup stuff.
There you go.
I'm
You're
adding
co-host.
adding it to the checklist.
Okay.
Cool.
Okay, so I'm gonna start screen sharing really fast. And talk about how this works at the very top level. So obviously we can do a very simple thing where we have some LLM, and if this LLM is given what we do in this LLM is we give it a prompt and we give it a list of categories. And I think the solution that most people have is somehow they add, oops, sorry. They take this list of categories and then they just put this into the prompt somehow, and then they hope that the LLM picks from these categories. I think that's like the most naive solution that we can do. Now, you can do a little bit better by using an LLM with structured outputs. Where you then go ahead and instead of putting it directly in the prompt, you're kind of putting in the prompt, but like there's a special part of the prompt that is, oops, the schema, and specifically
this
you add
is
the categories to the schema.
And like the OpenAI way of doing this, right, is like it basically is injecting JSON schema-ish things into the system prompt in a special way, right?
Exactly. So like that's one way to do it. Obviously, you can use the demo as well. But the problem that you run into when you go do this is you're still not really able to probe. The only thing you can really probe is this category list. And that
When
I
you
think
say
ends up being
probe, sorry, when you say probe, you mean like make small changes and see how they affect the outputs, right? Like, what do you mean by probe?
yeah, I think I come from like an electrical engineering background, so perhaps that's where my brain is going. But the hardest part about like circuits, whenever you do circuit design on any chip, is you obviously once the chips get really small, you can't really introspect them in any way. So often points, what you'll do is you'll build like little detection points where like you can actually go ahead and like go and measure and like manipulate the inputs or measure the inputs at certain points. The problem with LLMs, yeah, exactly. Jonathan got it. The problem with AI pipelines is we don't really get these probing points and we don't really get an area to manipulate this. Right now, the only real point that we have to manipulate these is the category list. But if the category list is like massive, how do you get an LLM to actually do what you do? So let's talk about the most trivial solutions that people have might have seen before. But like option one, once your category list gets really massive, is you take your category list, oops, and instead of putting it into here, you actually put it into a oh, sorry, you put it into a vector database. And I'll talk about why a vector database in a second. It doesn't actually have to be a vector database. So you put your category list into here. And once your category list lives in a vector database, then what you have is instead user query, instead of your user query coming in and immediately taking the entire category list and going with it, what we do instead is we draw into here and then we set down a smaller list of categories. and then we go into, and then we only pass those in instead. And this can do a couple of nice things for us. But instead of all the categories being selected, now we're able to prune this down to whatever count the LLM can go deal with. So hierarchical categories and multiple prompts is often what people think about, but often what I find is that actually leads to a lot of more confusion. And the reason that leads to a lot more confusion with hierarchical categories is because most people don't have clear definitions of hierarchies, and hierarchies end up bleeding over a lot more. So it ends up being a little bit more troublesome. And I'll talk about a technique of how you can use hierarchical categorization with this vector database technique to get way better results. But I think the general rule of thumb is every single LLM, no matter which one you use, operates really well on some count of categories. But I think the way that you think about which count of categories, like how many categories is able to selectively select from, really varies based on the categories themselves. And I think this is another part that a lot of people overlook. And I apologize for not writing code right up front, but I think it will help to have some framing of diagrams before we go and code it up. But let's say I have category A and category B over here. And if category A and category B are completely disjoint, I can have a lot more of these categories. Like I can have up to Z if they're all totally disjoint. But the minute I start having category A and category B overlap with each other, it becomes really hard for an LLM to pick the right ones. So if I have like if I have like 5 categories, but they're all really, really closely overlapped with like very, very small nuances differences, it's just not going to perform very well on an LLM scenario. I probably need a smaller prompt that is really good at disjointing only these 2 categories separately from each other to identify when it's one or the other, or could be either one. But if I have categories that are totally separate, then it doesn't really matter. Then we can get away with a lot more categories in the same prompt. In the case of like MCP tools, most MCP tools are very, very disjoint from each other. Sometimes there's overlap, but most of the time they're very disjoint. So we can get away with having a lot more. In the case of like hierarchical categories and hierarchical organization, there's actually a technique that we found works really well, at least anecdotally, in production that seems to work. But let's talk about what is nice about this approach. Now, there's this thing here that we all made an assumption of in our current approach, where the things going into the vector database are going to be exactly the categories, and we just apply an embedding on the categories and we put them in. But again, we don't really have any probe points in the system. We have a couple of probe points. We added another one, which is we can control how many, like exactly how we can control the count of these categories.
That's your
We can
like top
control
K in your vector
exactly.
search. Yeah.
Exactly. It's your top K in your vector search. So we get one control point. You want to label that, Dex? And then we get another control point, which is like we can choose what embedding system, what embeddings model we use. So now
And
we have
like the
2 control
content
points.
too, right? Like would you embed like a description of the category with the actual, like if it's like apple, orange, banana, would you describe that as well? Put it in the embedding.
So exactly. So that's where I would say like there's like a separate option here that I'm going to draw out, where a lot of people I think overlook this concept as a whole, which is the naive thing to do is to just put this category directly into here. But there's this more sophisticated thing that we can all do that can really give us a lot of control into the system, which is we apply category function category to the string. Let's see how well writing code works in here. Make this white. Embedding text, where you actually like return a custom text for every single category that you pass in, and that's the thing that you embed. And surprisingly, this becomes a really, really nice control point for us, because now whenever the model doesn't return something, doesn't select the right category, we have 2 areas to probe at. We can see, one, did the model select the right category? If it did, then okay, that means that this part of the system is good. If it didn't, then we know that we have to change the embedding text of either that category or the one that it's selected in favor of itself. So now you have like probe points that you can actually sit on that aren't your whole system. It becomes a special probe point just either for that system yourself. So if you have a category like that's for an MCP tool for like Slack and an MC2 tool for calendars, and it's picking Slack actions when it should be picking calendar actions, we can do different types of embedding text as a thing that we actually embed. And that can be a huge unlock in terms of your iteration loop. Now, the last thing you can do, the last probe point that I really want to talk about is up here. Now, once again, people often make the assumption that the embedding text that you put into here has to be the same embedding text that you put into your prompt. That's what they naively do. But the minute that you stop doing that, you end up in a really, really nice world where you no longer have to think about it that way. You can apply the selected categories can go through another function. Oops. Sorry. The selected categories can go through another function, which is LLM text, which actually tells you how to put the text into the prompt or the structured output or anything that you want for the model. So now we all have like two really key. We have three key points that we can go manipulate really, really easily that we can go introspect into our system. One point becomes the text that we put in for embeddings. Another point becomes the number of Ks that we select out of the vector database. And a third point becomes the actual way that we serialize the categories into our prompt. And obviously, you can add more and more sophisticated algorithms here in this system. But just with these 3 points, we can really make our system not really be as much of a black box that just happens to go do things, but make it a lot more controllable. I'm going to pause for a little bit. Dex, go ahead.
I got a question, and you can totally tell me like, yes, we'll do that in 20 minutes or whatever, and we're getting there. But I'm curious, like, are there established kind of like structures for doing kind of end-to-end testing on this kind of stuff so I can change my probe? Or is this a thing that people are mostly kind of hand rolling themselves and building a big table of evals for every single thing they hit in production?
Well, actually, you kind of have an eval built in. Remember, like in the end, what we're passing in is we're passing the user query as an input, and we're expecting some category as an output.
Yep. Right.
That's
Okay.
the
So
eval.
your prompt is basically some instructions on how to behave. It's
Yeah,
the user query, which is like, here's the actual thing you're classifying. And then it's a bunch of data about like what are valid input, what are valid output categories.
exactly. And
Okay.
again, we can add another probe here where it's like, what if the LM doesn't, we allow the LM to pick multiple categories. And then we
Oh,
apply another method after the fact to pick a single category. So we can do multiple levels of pruning as well. We don't actually have to pick one. This idea of going from many categories to one, in this scenario, we used a vector database. But if your system is truly, truly complex, we could have the LLM pick multiple categories. And it might be really complex because your categories have a lot of overlap. So we allow the LLM to pick all valid categories. And then we use perhaps another LLM if we want to
okay.
actually go ahead and turn it from a single category into multiple, and from multiple categories into a single category.
Okay, so you could have basically a function there in between the category list and the single category that is either deterministic or non-deterministic, depending on what gets you the best results. But having that
Exactly.
step there gives you it's like the right place to manipulate and change and kind of be able to do yeah. And this actually
Ex
this layer here becomes really easy to like unit test in isolation, right? You could just say like, hey, if the model returns these 4 categories and here was the input, we should always be returning this one.
exactly. And actually, I think that's the whole thing about this whole layer. If you really think about this whole system that I built, all we're doing in reality is we're writing a function that says pick category, or some text or some input, and we're returning a category type. That's all we're doing. We're writing a function that does that. And every single technique that we described from beginning to end, every single one of these techniques that we described, even the most simple one of just an LLM using structured outputs, using a vector database to pick a category, doesn't really matter. All of them are just implementations of this function, pick category. We just have different implementation of this function where we add more and more sophistication. Because if this whole thing is done by an LLM, then we know the only point of input we have is a prompt. But if we change this function, how do I change? Can you change this to monotext? Oh, there we go.
Yeah, there you go.
If we change this function to suddenly be like narrowed categories equals prune categories input,
That's
based
like
on
the
the
vector
input,
DB query.
It could be a vector database, it could be an LLM. It's just a thing that reduces the number of categories from many to some. But we can in our example, it is a vector DB, so I'll write that down. Right, so we prune the categories from a vector DB, and then what we do is like we say best equals use LLM picker input narrowed categories, and now we just return best. That's one variation of this system. We can add another one where it's like we can change the system to be best 3. Best 3, and then this returns the best, and then we go down there. And we can keep on making these systems better and better and better, and just keep on adding more steps into the system to make it more accurate. Is this a system that other people have ever built before? Just out of curiosity. Oh, so
Kinda.
let's get down to
We got a
let's get down
kinda
to yeah.
classifying for real estate.
Let's
Change
actually
grubs.
write this code. I think the best thing to do here is write the code.
Yeah,
Because it's gonna
quickly
make things
before
a lot.
Sorry,
Yeah.
quickly before you move on, just a question. On the transition from user query to the selected categories, like how are you coming with the selected categories? Are you doing a similarity search within the
So
vector
we
ID?
can exactly. So we can do a similarity search from a vector database where you find the top K out of it.
Challenge is
Or
the
you
user
could-
query might not reflect the. Does it really? So you mean to say the semantic embeddings would fall closer, and that's how you're able to pick it, right?
Yeah, and if it doesn't, we can force the semantic embeddings to fall closer by changing the text of how we embed the actual category. So usually what people do when they add an embedding is they just take the raw string and add it directly into the vector database. They say, here's the category name, add it to the database. But what if the thing that we actually embedded into the actual database was like this? We put the name of the category, and I'll zoom in over here. We put the name of the category like this, right? We put the name, we put like example 15 example queries that match it. And then we put like another like 20 scenarios. And then we put like a list of like 20 keywords. So now we have this ability to almost force the embedding to be closer to the thing that we want it to go be into. Because now instead of just like adding, and how can we get these? Literally, you can just LM generate these. That's what I do. I LM generate. The initial thing I do is I LM. Can you mute that person?
So I'm really about it.
I don't know who that
I
is.
have you.
I got it.
Yeah, thank you. So you can actually like LM generate these, or if you have a domain expert in your company, the domain expert in your company can actually go ahead and go do this as well. And this will end up working quite well. I've seen this work many times for many companies that have like over 500 categories plus. And the key part here is because this becomes a thing that you control now, you're not reliant on the model to produce the best results, because the embedding model is a black box. Neither me or you or any of us can really control it. Yes, we can fine tune a model, but like fine tuning a model is so painfully slow in your iteration loop that like if you fine tune it wrong, now you have to go back and refine tune the whole thing.
Mhm.
But if we have strings that we're using to manipulate the actual vector that we generate that we put into the embedding system, then this becomes really, really fast to go do.
So Vaibhav, taking an example of, let's say my categories are a bunch of columns within a table. In that case, the way I'm embedding the text here is maybe the column name and with a bunch of description around it and maybe a bunch of questions that it can answer. Embedding that whole stuff in it, is it?
Can you say that one more time? Sorry, my headphones cut out.
I'm just trying to think about an example. So we are not going to embed the exact text that we have. Instead, what we are saying is describe it in a better way, write it
Yes.
more verbose, maybe. I don't know. But
Well,
taking an
whichever
example,
way. Yeah.
taking an example of column names in a NL2 SQL kind of solution where you have to kind of classify which columns would you use for your SQL query. In
Yeah.
that case, multiple columns would come and you would eventually write a description for it. Maybe you would write a bunch of queries that these columns can answer, and then embed that kind of text to here and then use that later. But in the top, if I go where you are going from selected categories box to the prompt and you have this function LLM text category in between, what is that doing here?
So now there's another part. So we have one probe that we want to manipulate the embedding vector so we can get more likely the categories that we care about.
Mhm.
Now there's another thing you can do, which is the way that you put the text that you use to get the best embedding out of the vector to make it match your user query may not be the same text that we have to do to put the to make the LLM pick the right category. And recognizing that these two texts are very different because the models under the hood are very different is an important distinction to hitting really high accuracy.
Understood.
So like
Yes.
here, this thing might want a name and then like just a plain text description of its use.
Understood.
But right, if
Right.
you put in 15 examples, you're gonna kind of poison the LLM and like do this like issue we see in few shot prompting where you kind of like influence the behavior too much.
Yeah.
Understood.
But recognize that we can have two. Now recognize that we could use the same function as well. It's always possible to use the same thing, but it's more about building probes into our software so that when things don't work, we have a thing to change that isn't like praying to the prompting gods.
It's exactly what I've heard you say a bunch, which is basically it's like I don't know what the best approach is for a given problem space, but I know that the more control you have and the more knobs you give yourself access to, the faster you're going to find the best way to solve a particular problem.
Exactly.
And what about top K here? So I see me and other people struggling with the top K value because you are not never sure. 3, 5, you miss it, you underpin it, and you get less data into the context. So is there a way around it as well that we have figured it out already?
Pick top K.
Yeah.
There's no, I think it's just a probe that you have to go decide. And I think the best way to look at this is now the system becomes an introspecting system. So if I know what I'm expecting for a certain user query, let's say I'm expecting category A for a certain user query. And if I look at the vector database, I see that A doesn't come out when my top K is 3. Then I know what I have to do is I have two choices. I can increase top K or I can change my embedding category, embedding text.
Or 6 of the other probes you have out.
Well, I think these are the only ones that we can modify.
Can you modify
right.
LLM text? Oh, I see.
Yeah,
But
so
it's the end-to-end thing, right?
Well, yeah. So, even though it's not, even if it's not coming out end to end, my first approach would actually be to see where is it failing.
Oh, you can test
making it to
just
the
between You can test just between the user query and the selected categories and optimize just that loop to make sure that at least the category that you're looking for is in that selected batch. And then you have fewer knobs that you have to turn. Okay.
Because if it's not in this batch, then there's nothing I can do about it. The LLM will never get it right. So at least now I have a waterfall-based approach where I can be like, what? It's like when I'm step through debugging in code. It's like I like to know how far did I get the right answer and when did I get wrong. If I know that this answer has the right system, then I can just go work my way down and be like, okay, this thing was correct, but this thing is not correct. So I know I need to focus all my debugging energy on this, not on this. So it allows me to know that the thing that I should probably modify is not embedding text, but LLM text. Does that answer your question, Anubhav?
Yes, yes. I think it's more around precision K measurement kind of thing that we do.
Yeah, and you just have to sit down and pick the top K. Like there's no, and top K, by the way, here is the number of vector entries to return from a vector database match.
Correct.
It isn't the same as top K in an LLM, just to be very, very particular.
Yep, yep.
Any other questions from anyone? No. Okay, let's do some code. What is the disadvantage of having an can you read that question out to me, Dex, while I set up the code?
Yeah. So it's essentially like, what is the disadvantage of going back to 0 probes, but have 2 LLMs spend a few cycles in some kind of evaluator optimizer workflow? And then the probe is just the stop condition for this workflow. While you're coding, I can kind of try to tease out the question there, or Nirmal, if you want to come off mute and kind of give a little more color. But sounds like, I mean, I think those are just different kinds of probes, and your probes end up being like, what are the prompts and what are the number of cycles and how do you have those 2 LLMs collaborate with each other? And I think kind of the big lesson to take away is like, maybe you don't use a vector database, maybe you don't use hierarchical categories, but whatever you use, like, how do you chunk these up into smaller problems where you can tweak smaller knobs and evaluate the performance of kind of some of these like sub functions? Does that sound right?
Yeah, I think, that's basically, it sounds right. Basically, what I'm driving at is that my intuition is that if you have a lot more probes, it does add introspection, but that introspection is also going to come at a cost, right? Like there's going to be a cost of having 1 probe versus 5 probes. The knobs, having more knobs is going to also make the debugging or introspection more complex. That's kind of where I'm driving at.
The only real problem, normally I think that's correct in software, but the big difference in the software that we're writing with models today is that ends up being way worse, because you actually have the worst system right now, which is a model you cannot modify in any meaningful way. So when it's a complete black box, you have effectively no probes in the system except the prompt. And the prompt is just not a great place to manipulate it when you have, as your prompts get bigger and bigger, any individual manipulation you make has more and more consequences. So if you're picking between like 100 categories and picking between 5 categories, changing the word in 100 categories is way more likely to poison your output than with 10 categories. And I know that sounds a little counterintuitive. And the reason for that is just because you're not going to be able to manipulate the model as quickly by changing a word. So you'll have to change a lot of words when you have 100 categories. And now the model will be less likely to do what you want in other scenarios. So I think the way that I look at this is you end up in a scenario. Sorry, my dog is looking at me. Like when you have when you have more of a model system, you basically are like building a really, really good Gaussian distribution that has really bad standard deviation. As we add more and more probes, what we're really doing is we're trying to make the curve look more like this. We're trying to remove these soft edges and pull the model in closer and closer. Oh, sorry. Come on in. You can put them in. You.
Yeah, I mean, I think that comes back to kind of the core thing, right? Is like if you're just using LLMs and just using prompts, like yeah, you could have 6 different prompts and those become knobs. And if you have smaller, like you could do
Yeah.
all the vector stuff with just hey, let's loop over the instead of doing embeddings. I've heard a lot of people have success, and I don't know if we'll have time to get to this today, but like rather than doing RAG, just pass every single option through a small model with a very specific prompt, which is like is this relevant to the query, and use that to cut the data set in half and cut it in half again and do things like that.
Yep.
It's like the point is like the smaller and simpler the steps are, the easier they are to optimize, right? Yeah,
There's
prune categories. There you go.
You nailed it, Dex. That's exactly it. There's nothing that says that prune categories vector DB has to be a vector DB. This could be a bunch of models that take in every single category as an option, like Dex said, and just return it and select only the ones that are relevant to the model.
Yeah, or determine just thumbs up or thumbs down. Is this category kind of relevant, or is it totally
Exactly.
unrelated? And just use a Boolean classifier, right?
Mm-hmm.
All right, cool.
Okay, I'm gonna start off writing the code in very pseudocode format because I think it's just gonna help us know how to go piece everything together, and then I'll actually go execute it and make it work. So we're gonna have one thing that's gonna load the categories from somewhere. Dex has a bunch of categories that we have, so we'll go load that up in a second. We're gonna have a category which is gonna have embedding text, so the text that we use for the embedding, and an LLM description, which is going to use which we're gonna use for like the LLM. Now we're gonna have one function that's gonna be able to narrow down categories. So I'm gonna give it some text and a bunch of categories, and it should return to me some list of categories that is here. And this function owns everything like top K and everything within itself. We don't really care. Now what we'll do is we'll have another function that says like pick best category, where we'll give it a list of categories and it'll pick another category. So our code actually ends up looking relatively simple. And these are all like private functions, so I'll put this here. Def pick category. So given a text, we should be able to narrow it down. So given some text, we're going to load all the categories. We're going to narrow down the categories, then we're going to pick the best categories. That's all this code ends up being. It's not too complicated.
Is there, sorry, are we missing a step that is like, because in ours it was like filter the list down and then pass it to the LM to do the classification and output the list. And
so that's
then, okay, that's
so
gonna
we're
go in
not
here.
gonna we're not gonna let the LM pick multiple categories right now. For now, we're gonna let the LM,
Okay.
we're gonna force the LM to pick just one.
Okay, cool.
So that comes down into here.
Cool.
And then we're gonna list that, return the actual category that we want. And specifically, let's just say like we're gonna return a string, which is the actual name of the category that we want. So we'll return like category, we'll return category that name, just to be a little bit more pedantic on what it's doing. So now let's go ahead and go do this. Let's implement how narrow down categories is going to work. So this is going to be embeddings equals this. Cool, that it's kind of doing this for me. Embeddings that append, and specifically I'm going to append the category itself as well, so I have access to it.
Okay, so you're appending a tuple there of the like the category itself becomes the label on the embedding, right?
Exactly. So that way I can just go like find it really fast.
Yep.
So then I'll embed the text, and then I'll find like cosine best matches. That's funny. It actually did it for me. I don't know. And then this is going to return sorted matches of this based on this, and then let me just import it by. Add numpy. So this code ends up being fairly straightforward. It's just like an embedding system, and I'm not even using any LLM or anything. I'll define the embed method later. We can use any sort of embedding system that we want. We do a cosine similarity. It puts all the categories into here, and then let me to make this better. There you go.
Nice.
So now we get slightly better. Best matches. We'll get all the best matches, and then we'll sort them, and then we'll return what we'll do is max matches will return like 5. And we'll return that. So now this will actually go return matches. There you go. And now we're actually going to go turn those categories. Here, I'm gonna go turn on. Oops, sorry, I'm gonna zoom out for a second. Turn on type checking mode. For some reason, Python has chosen not to make type checking be a thing by default.
I mean, the types are fake, right? They're all they all disappear at runtime anyways.
I know, but it still annoys me to no end. So now we're able to narrow down the categories. Now, I think the next part is the most interesting part, which is how do we get an LLM to go do this for us? Like, given a list of categories, how do we get an LLM to pick out the right categories? This is what I usually do. I write a function, pick category. We write a function. This job is like pick best category. It's going to be given some text. And then we're going to return a category type out of it. And category will be an enum of category. But this enum is not one that's going to be described in our BAML code. It's actually an enum that's going to be described dynamically at runtime. And we'll use OpenAI GPT 4.0 mini to go do this. Which category best describes the following text? ctx.output format.
So that's going to output the list of categories that it should use in its answer.
Exactly.
And then as the user message, we're actually going to put in the text.
So let's just take a look at what this prompt does really fast. So here's what this prompt is going to do. And I'm going to use GPT-4o mini. Which category does this? Now there's no categories here, so let's add categories at least for this test case. Type builder, dynamic. And we'll write like a category 1 at description or placeholder text.
Okay, cool. And that's being built out kind of on the right, dynamically added to the prompt as you add those categories.
So we're adding categories dynamically for I don't know, what is this going to be for logging.
Okay. So
log levels.
In
logs.
Yeah. So when we go get our big list of tools that we slurped up from a bunch of MCP servers, basically, rather than this category 1, category 2, category 3, we'll be injecting those categories into the prompt like this.
Exactly. Well, and then if we go run the stats, what we should see that this should, in theory, it picked category 1, we're good to go. It actually said category 1 for placeholder text, but we got out with the thing we wanted, which is category 1. So I think we're good to go here. This function should, given a bunch of tools dynamically, be able to select this. So now let's write this category tool. So what we do is from BAML client import v. Python is dumb. It needs to be reset. B dot pick best category. We're going to pass in the text into it. Matches. Pull this. But now we actually have to build the type builder so we can actually dynamically pass in those categories into it. There we go, autocomplete. And what we'll do now is tb dot, we have the category enum that we defined programmatically in BAML, dot add value. And we're going to add a bunch of values into here. So what we'll do is for category and categories.
Okay, cool. So at some point, we're going to need some kind of global var somewhere to load in all the categories from JSON, or kind of just like hard code them in the source here to start, right?
Exactly. And then what we can do is val.description. And we can just pass in category.lm description into it. So now
Because
we're
that's what
actually
we that's our second or third probe or whatever it was where we can
It's our
kind of
second probe.
customize how we describe it
Exactly.
to the cool.
Now, to make sure that that probe has really, really high value, I'm actually going to add an alias into the system. Where I add an alias, and I use an alias as my default one. And
And what does that
why.
do exactly?
I'll show you in 1 second exactly what it does. So here's what an alias does. Let's just look at this prompt and let's go add an alias so we can go see this. Add alias K0, K1, K2. So it's actually changing my prompt. It actually takes the name of the category out of my prompt and only puts in the description. That helps me in a couple of ways. Remember, we're talking about probes. So we want to make sure the probes we have the most amount of impact into our prompt.
I see. So you don't want the category name to like cloud. You want to basically be like the only thing the LLM sees is what we have selected to be the thing that the LLM sees. And the category name can be whatever we want that makes it easiest to write the best, cleanest code. But that when we pass things into the LLM, we want complete control over what the LLM sees.
Exactly. So the LLM saw K0 for placeholder text, and it was able to like, it basically takes none of its attention metric and puts it onto K0. It puts all of its attention metric onto the description that we want, and it recognized that K0 is purely an identifier. And now that it knows K0 is an identifier, it can go and like spend all its energy. We don't have to worry about the nuances of words overlapping. Because what if you have a category called account issue and technical issue? And the descriptions are very unique, but the names kind of overlap. And single word names tend to overlap by default. So when you have a lot of categories, alias can give you a lot of power. You can like remove the concept of whatever like subtext the name comes with and purely add it into category and like let it focus on just the category itself.
Oh yeah, and our example data set has a lot of tools with very similar names, or like the same different MCP servers have tools with the same name in them.
Exactly. And now I have a bunch of matches, and now I have to do something slightly inefficient, which is I have to go in like for
I thought it only returns one match.
Oh, sorry, but I can't use the match keyword because that's the word. Selected category. So it has a selected category, and I do for category in categories. Return this, and then I just do this. And this should be impossible to happen because BAML will guarantee that this will return one of the categories in the list.
So this is just like triple checking that the LLM returns something that's in our list, and it didn't like hallucinate some category.
This is specifically trying to return the type that we returned here.
You're just looking up out of our list. Yeah. Okay.
Yeah, because exactly, because this list is different than like the string that this is returning.
Right. You want to return our like native category object by matching on the name.
Exactly. So I want to return our native data model object for matching on the name. This is all the code is here. That's all we have to do. And now there's clearly things that we can do here to manipulate both of these. And
yeah, can we throw in like a const, just like global list of a couple categories? Oh yeah, here we go. Okay. Wow, it's like Cursor is listening to me over the Zoom.
And right now you're clearly seeing what I'm doing. I'm passing this in as is. There's no real difference here. And then let me get an embedding API really fast. There's probably something here.
How come this seems like it's installed upside down? But yet this holds the grill.
Okay, I'm gonna go make executive decision. That's not about our problem here. For a second, I heard installed upside down. I was like, is that a comment on the code we're building?
I also did doubt my own coding skills for a few seconds there.
Okay, he's actually a plant. I figured we would give you some self-doubt in the middle of this. There's your surprise challenge. Hey, look at that.
Does it do that? Why is it not auto-completing? There's something wrong with it, I think.
Do you need to add the types for it?
Oh, it's in there. Maybe it's just a little slow.
Sorry,
but
you
it
getting
makes-
an error?
It just says unknown, and I get very angsty whenever I get unknown text of any kind. And then I think, well, I think this will work. And this was the trick. Let's just do it really fast. Let's run this code.
Ship it.
Shall we do this? And I have my OpenAI key already plugged in. UV run hello.py. Oh,
Wrecked.
import.n.
Can you do me a favor and just cat your .n file for me, just so I can make sure you've set it up right?
Yeah, of course.
All right.
What did I do?
Oh.
Oh, I didn't actually feed in the categories. That was a bug. I actually never fed in the categories into my system. I actually have to tell this function that I'm passing in a type builder object into it.
Oh, nice.
And we'll actually see exactly what this does. So now you can see, and it picked the debug category. Let's add a bunch more tools. So I'm just gonna cursor to add like, I add 15 tools categories here that describe user intent on a e-commerce on an e-commerce site. This new cursor thing is annoying me to no end. I don't know why the auto mode never works.
We're almost at time, but I'm happy to run over for a little bit if you want to try to do this like thousands of tools list.
Yeah, let's do it right here. So I added like, let's do this one really fast.
Yeah.
And
then I'll send you the JSON file. You could just paste that into Cursor probably, and it will generate everything you need.
So I put here, I want to buy a new phone. We can see our like little, we see our little text over here, and we'll just see what this does. How many categories? I only let it pick 5. So you can see what it was able to do. It actually did search products. I want to buy a new phone. And now I can go and see exactly what happened and where it happened. So the first thing that I noted is user is looking for deals or discounts, looking to search a product, looking to add a product to their shopping cart, or wants to sign up for an account.
Okay. So
what it
you
says, like-
actually, this is the narrowed categories that came back after the cosine comparison.
Exactly. I want to buy a new phone. And like that looks about right if I had to really pick one. Where it's actually able to go ahead and say that the user wants to go pick a product. Now, it's possible that I had a thing in here called, let's add one, buy product. Let's add that in there and just see what happens when I start running the same script again. And I can start to see kind of what's going on. And obviously you can do things like cache seeds, embeddings and everything just for like the purpose of expediency. I'm trying to do it right here. So the first thing here is like, we can see that now this popped up in my embeddings list, so it's actually able to go select it. But if it didn't pop up into my embedding list, then I know what I have to go modify. All I have to do is modify the embedding text of the buy product category. Like do something with money. Like I'll change my category right now to do something with money for my embedding text. And what we should be able to see is it didn't pop up. So like, of course, the model won't be able to select it because it's not even one of the categories that's available to the model to buy. So it gives me a really nice way to go probe it and go manipulate the system that doesn't affect my whole system holistically and every other outcome as much. It allows me to tweak just the parts that I really care about, and now I can get really fine-grained control in certain category systems. I know we're about 2 minutes left to go. I'm gonna pause really fast. Any questions from anyone?
Oh man, I got that reminder too.
But is LM description the thing? So you're asking, is LM description the thing it is? Let's look at what LM description does. All I use LM description for is it's actually going ahead and adding text. Whenever I add the category into the LLM, I'm adding some context associated with it. So the category often has context. And now I can go ahead and actually add context on exactly what this category is. And that's what the description is doing for me. It's the text of the description for that category. So the model kind of knows what that category is used for in context. And that text is very different than the embedding text because I may want to manipulate it in different ways. And all this
Okay,
code
cool.
will be pushed to GitHub. I'll send the GitHub repo out right afterwards.
So all those functions we wrote as probes of like, you know, embedding text, and we're really just encapsulating that as fields on the class, basically.
Exactly.
Yeah.
And like we can do different things. We can have them saved in a database. We can have them living in a live database that we're constantly editing with our users. For example, like our users could be given this context. But that's kind of the goal here.
Question.
Yes.
Is a video recording of this going to be sent out to you afterwards?
Yes, the video recording and the live code will be sent out afterwards. And if you'd like, I'll give you some homework as well to go play around with it with a data set.
Love homework.
Yeah, there you go.
If you guys found this to be really useful, we'd love for you to just go give us a like on LinkedIn when you see the next one. If it sounds useful, start the GitHub repo for BAML and human layer. Always have to ask. It's part of our job as founders. We hope that if you send out more questions or more topics that you'd like us to cover next time, we'd be glad to go do that. And then we'll stay on for an extra 10, 15 minutes answering any questions if people have them.
Perfect. Hey, thanks everybody. And yeah, I'll be hanging out as well.
Yeah, now's the extra time if anyone wants it.
So, quick question.
I'm
You have
also gonna
dynamic,
stop. Yeah, go ahead.
dynamic enum. So, what is the purpose of that? Since like of that existing, because at least the way you had the example, you were putting all these enums in there. So that presumes that because
So
it's linking to.
the whole reason that this exists is for a couple of reasons. So one of the biggest reasons is, as we know, the LLM is not always going to spit out the same text every single time. Sometimes it spits out K0. Sometimes it'll spit out like it'll say text like this, category dash dash dash dash K0. Like this is garbage. If we relied on the LLM to do this, then you'd have to do a lot of parsing. BAML is able to say that based on the data that you gave it about the enum, in this case, we know that we have these categories in here. We know that the user is expecting only a category object. So we can run all the algorithms that BAML runs for you and spit out just a category under the hood. So you are guaranteed, no matter what, when you call this function in your Python code, this function over here for pick best category, you are guaranteed that selected category will match one of the enums coming out of the ones that you set into here.
Got it.
So
Okay.
it helps you provide a guarantee. And because these things are set dynamically, yeah, Dex, if you can put the LinkedIn post to today's session, that'd be great.
Yep.
If you could basically have this guarantee, then you know that this is now a reliable pipeline that will return one of these. So now this for loop will always work, and then this is just impossible. Like if that ever happens, like impossible code happened.
Yeah, it's I think the gap was just in sort of the interplay between the LLM and the text that it's injecting and what you're playing back. And then you literally said it. I'm like, oh, yeah, obvious, duh. Okay.
No, it's not obvious. I probably said it like way too fast. I should have slowed down. So, any other questions?
I have a question about latency.
Yes.
So you mentioned about in your Excalibur diagram that you could have like 3 to 4 different stages where you probe. So what is the implication of this? I know people are using open source models to bring down costs for a lot of these things, but they're slow. And then if you don't use the open source models and you have, I don't know, hundreds and thousands of API calls, that adds both cost and latency, right? So there's a trade-off between doing too many of those versus increasing your
So
application's response
this
time.
approach, this approach actually ends up being way faster from a latency perspective. Because narrowing down your categories is really fast. We're using vector databases. So
Okay.
it's really, really fast, right? And I'm running this locally. You can have a vector data. Most people have less than like 100,000 categories. You can literally
Of
run
course.
that in memory in your machine without any other software. You don't need to actually use a vector database. Like you saw
Yeah,
that I just ran
makes
this
sense.
local, I just did this, and you just cache the vector, you cache the database file in some like random pickle object on your system. And obviously you can do this in TypeScript or anything else you want as well. But you cache
Vaibhav,
that.
do you have the Excalibur
What?
window open? Could you go back to that again?
Yes, I do.
The vector database part I get, but the parts
You're talking
downstream of
about this
that.
part.
Yes, this part.
Yeah. So it turns out that because the number of categories you're sending into the LLM itself is way less than the original kind of categories, you also get way better speed up. Because imagine you're passing the LLM like 500 categories versus 20 categories. The LLM will respond faster with 20 categories. LLMs are quadratic in nature. I mean, like non-linear based on the number of input tokens you have. So if your input tokens, they will be a lot faster.
Awesome. Yeah, makes sense.
And if we change this function to like, let's say we change this function and we say, instead of pick best category, we want to write the same thing. Pick best categories, count, int, and we return an array, which count best describe the following text. And now we can return multiple categories out of this system. And then we can run another narrowing search that says, given those categories, now prune it down and add more categories into it, if that makes sense. So
makes sense.
Right? So we can write another function in Python that says like pick multiple categories and call pick best category from only those categories. Like narrowing the categories just happens to be a thing that we're doing with a vector database. You can easily call def narrow down categories LLM. And this will return like categories. Oops, selected categories. And then I guess it did this for me. And then let's say I want to return like 3 categories. Now I'm returning 3 categories from the ones that the LLM picked, and then I'm calling this down. And now my pipeline can be this. So I'm kind of choosing where I take in the tax of my system. I don't have to do this if I don't want to.
Yeah, I think a really natural follow-up to all of this would be like, how do you write like unit tests and end-to-end tests on all this stuff? I mean, I might even be down to like I think we have another topic for the next session, but we should find some time to just like, hey, how do you make this all the way to like production grade engineering rigor of like in terms of testing each individual part and then testing the whole pipeline end to end and building up your eval set for how we want this to work.
Yeah, that's a good point. We should probably consider a topic on that. And how do you go from this to like an eval pipeline that you can actually go and test? Because that's a whole different workflow.
You can, every time the model gets something wrong, you can quickly spin out new tests at the like probe layer and at the end-to-end layer. And then go iterate on your prompts or your embedding algorithms or your top K or whatever it is.
You want to see how I do that? I can do that really fast. I'll go do it really fast. This ends up being like way faster than most people expect. So
here it comes. Here it comes.
Let's go to test. I'll go do this, and in theory, let's see if this works. And more API key.
Fine. I will follow up and remind you to rotate that key before we share the recording.
That one. Oh yeah, that's okay.
It's okay. I already took 3 screenshots.
Advanced sharing options, which is how do I stop screen sharing for like 1 second? Because now I actually do.
I think you can pause screen share and it will keep everything, but just like
that's great.
freeze it for a sec.
Thank you. I do need to check my .env file. I'll play again. So here's how I do it usually. And this will give us some nice little probes. Import trace. And what I want to do is I want to trace this category, this method, and then I want to trace this method. And then that one will be traced for me automatically. And also trace this method as well. No, I don't need to. Okay. So now I'm gonna go rerun the same thing. Clear. In theory, this should pop up and go do something. So we see that I want to buy a new phone. So return search products. And what I can go do when I go debug, and I do this for all my eval sets.
This is a great preview.
See the system that I'm able to get, and I can see, okay, what did narrow down categories do? It actually returns some of these categories. Oh, I need to change the stir object here. The new system does that slightly better. And you can see exactly what the LM actually picked out of. And then what you do is you can debug and say, was the problem the fact that this didn't have the right categories and it didn't pick the right thing? And in this case, I can clearly see that it's the case. Like I don't have the ability to buy a product. So it had to click search a product. So clearly something went wrong in here. So then I can go ahead and go and update just my category. Then I know I have to go and debug my iteration loop on only the embedding text. And really nothing else. So I go, so then I go and just update my embedding text. And I think if I do like if I make this a base model, for base model, then I get slightly better. Then this should work a little bit better. Oops.
Oh yeah.
Does this not work in Pydantic?
You have to use the keyword args. You can't use positional args.
I think it's also you can use data classes, but anyway.
Oh, okay. That probably explains it, but it's okay. I have AI to help me write my code faster and better. And then you'll basically get the category object plumbed up. And that will kind of give you more data. And this I find to be a really fast introspection way for me to really quickly just understand where my system is broken and like where it's actually not working. And then if I rerun this again. Oh, category has no field. This is not a Pydantic object. I maybe have a bug in my code somewhere.
Cool.
I'll figure out where the bug in my code is and I'll go upload it when I go upload it. But the debugging flow of being able to introspect and see exactly which part of my pipeline messed up is really the eval set. And really the best eval you can have is, yes, you write down like 50 PyTests yourself and you call this function, you write asserts on them. But the best thing you can do is actually to ship this product into the user database and actually go and collect this data off your user queries and then go and evaluate the pipeline and see where it's going wrong. And if you can somehow associate that the user intent didn't match the thing that they did. So if you suggested an action based on what category you picked and the user said nah on that action, then you can always go back and say, okay, then I know something was wrong. Let me go introspect as a developer and go see what went wrong. And I can see, was it in the narrowing down or was it in the actually picking? And that can help me
Yeah.
navigate this faster.
Yeah, and that's the thing I think in like product dev in general is like having engineers have direct access to user feedback on what LMs are doing. Super important to
Yeah.
like have that tightest possible iteration loop. Cool. Other questions?
Other questions?
Web, is this the observability tool that we have? Is it currently available to be on-prems as well?
That will be available in about 4 weeks, I believe. And then yes, it is. We have a couple customers that are asking for on-prem, so we've been working on that.
Okay.
Yeah.
Okay. And is the sign up still free? I thought it was first
Yeah.
quarter. Is it?
It's going to be free for about 2 more weeks. And then in about 2 more weeks, it will no longer be free. So use it while you can.
Okay.
But we have a new version that's even better, and it'll have a freemium option on it for people that don't have high volume of data.
All right.
Other questions? Cool. I think next week's topic is going to be really fun. I'm really excited to talk about the difference between like reasoning models and like versus reasoning prompts. Me and Dex talk about that quite a lot. Because like now these reasoning models are coming out, the question is it better to offload some of the work to the model and let it do its own reasoning? Or is it better for me to control the reasoning in my prompt like we did today? And like in all things in ML, the real answer is my favorite little meme. It depends, SpongeBob. Oh, they don't have it? It depends. And we'll talk about when and where next week, and we'll have a lot of fun. And I hope we get to see you all again.
Absolutely. Thanks everybody. Thanks, bye Bob. Get you all in the next one.
Thank you, everyone. Dex, this was really fun. Thank you for joining me.
Super dope.
All right,
Next
thank
time you're gonna have to
you.
let me write some code too.
Yeah, we'll do it. Next time we'll have you writing code.
Oh God. All right. I love it when Fi Bob yells at me while I'm writing code. That's one of my favorite experiences. Have a great week, everybody. Catch y'all later.
All right. Bye.